Hey, hello everyone. Today we are going to explore the concept of a singly linked list in Python. A linked list is a popular data structure which is used for storing and organizing data in a sequential manner. Specifically, we will be focusing on a singly linked list which consists of nodes which are linked together through references to the next node in the list. So now let's dive into the code and understand how it works. We start by defining a node class. Each node contains two main attributes: data, which holds the actual value, and next, which points to the next node in the list. This way, nodes are linked together, forming the linked list. Next, we have the linked list class. This class serves as a container for the nodes and provides various methods to manipulate and traverse the linked list. Upon creating an instance of the linked list class, we initialize the head attribute as none. This signifies an empty list. The create method allows us to add elements to the linked list. It takes an input value and creates a new node with that value. If the list is empty, the new node becomes both the head and last node. Otherwise, it appends the new node to the end of the list. The display method traverses the linked list from the head node and prints the values of each node until it reaches the end. This allows us to see the elements stored in the linked list. The insert method lets us insert a new node at the beginning of the list. It creates a new node with the given value and adjusts the references accordingly to make it the new head node. The delete method removes the first node from the list. It updates the head reference to the next node and deletes the previous head node from memory. The reverse display method provides a way to print the elements of the linked list in reverse order. It uses an auxiliary list to store the values of each node in reverse order and then prints them. The insert first method is similar to the insert method. It inserts a new node at the beginning of the list, making it the new head node. The insert last method allows us to append a new node with the given value at the end of the linked list. It traverses the list until it reaches the last node and then adds the new node. The search method lets us search for a specific element in the linked list. It traverses the list, comparing each node's data with the given key value. If a match is found, it displays the position of the element in the list. The alternate display method prints the elements of the linked list by skipping every other node. It does this by traversing the list and printing the data of each node while skipping the next node. The count method counts the number of elements in the linked list and displays the count. It traverses the list while keeping a count variable to keep track of the number of nodes. To interact with the linked list, we provide a menu driven interface where the user can choose various options such as creating a new node, displaying the list, inserting, deleting, searching, and more. The program will execute the chosen operation and continue until the user decides to exit. Let's go through the variables and functions used in the program and explain the significance of each line. The variables used in the programs are data and next. The data variable is used to store the value of each node in the linked list, and the next variable is a reference to the next node in the linked list. The functions used in the program are listed. The first init method is called as a node class constructor. This function is called when a new node object is created. It initializes the data attribute with the input value and sets next to none. The init function is called when a new node object is created. It initializes the head attribute to none, indicating an empty list. The create function allows as users to add elements to the linked list. It takes an input value and creates a new node with that value. If the list is empty, the new node becomes both the head and the last node. Otherwise, it appends the new node at the end of the list by updating the next reference of the last node. The display method traverses the linked list from the head node and prints the value of each node until it reaches the end. It uses a temporary variable temp to keep track of the current node and moves to the next node by updating the temp to temp.next. The insert method allows users to insert a new node at the beginning of the list. It creates a new node with the given value and adjusts the references accordingly to make it to the new head node. The new, the new node's next reference is set to the current head and the head reference is updated to the new node. The delete function removes the first node from the list. It updates the head references to the next node in the list and deletes the previous head node from the memory using the del keyword. The reverse display method prints the elements of the linked list in the reverse order. It achieves this by creating an auxiliary list A and storing the values of each node in reverse order. Then it iterates over the elements in A in reverse and prints them. The insert first function inserts a new node at the beginning of the list similar to the insert function. It creates a new node with the given value and adjusts the reference to make it to the new head node. The insert last function allows users to append a new node with the given value at the end of the linked list. It traverses the list until it reaches the last node where temp.next is none and adds the new node after it. The search method searches for a specific element in the linked list. It takes a key value as input and traverses the list, comparing each node's data with key. If match is found, it displays the position of the element in the list. If no match is found, it prints a message indicating the element was not found. The alternate display function prints the elements of the linked list by skipping every other node. It achieves this by traversing the list and printing the data of each node while skipping the next node if it exists. The count function counts the number of elements in the linked list and displays the count. It traverses the list while keeping a count variable, which is C, to track the number of nodes. Additionally, it prints the data of each node as it traverses the list. Last one is the main program. The program provides a menu driven interface to interact with the linked list. It uses a while loop to repeatedly ask for user input and execute the corresponding operation until the user chooses to exit. Each line in the program has its significance in implementing the various functionalities of the linked list, such as creating nodes, updating references, traversing the list, and performing operations based on the user input. Together, these variables and functions enable the creation manipulation and visualization of a singly linked list data structure in Python.